Okay, let's unpack this. We're looking at something pretty extraordinary today. It's not just an architectural RFP, not by a long shot.
No, this is something else entirely.
We have the KING-KAMBUF Nation Building Design Command Brief. It's from the services of KING-KAMBUF PS Architecture Design Studios, dated for a session on December 2nd, 2025.
And right away, you can tell this is a blueprint. It's a plan for national hard infrastructure, and the ambition is just staggering.
It really is. This document feels like every design choice is being framed as national policy.
That's exactly it. And the focus is crystal clear from the title. Structural gateways, bridges, viaducts, and mobility spines for KAMBUF city-states and diaspora corridors.
So we're not talking about, a simple local traffic bypass.
Not at all.
We're looking at infrastructure designed to carry people, freight, and data across continents. It's linking African heartlands with these global diaspora hubs.
You're right. It's defining the movement of a global nation, but doing it with concrete and steel.
And the brief is very specific about what these structures need to be. There's this dual functionality baked right in.
Precisely. On a practical level, they have to be redundant, climate resilient. They're designed to stand above historic floodlines, to bypass what they call catastrophic traffic congestion, and just to ensure that logistics keep moving even in extreme weather.
Which is a huge challenge in itself.
A massive one. But then there's the other side, the symbolic side, which is just as important. They're explicitly defined as ritual thresholds.
What does that mean in practice, a ritual threshold?
It means the structural language, the look and feel of the engineering has to be so unique, so definitive, that the moment you step onto that bridge or drive under that viaduct, you feel that you are within KAMBUF jurisdiction.
So it's sovereignty through engineering.
That's the perfect way to put it. It really is an exercise in sovereignty through engineering.
And this whole vision, it's not some far-off dream. It's driven by some very real-world pressures.
Oh, absolutely. The brief brings up the AfCFTA, the African Continental Free Trade Area.
Which is, it's the centerpiece of the continent's economic integration strategy.
Right, but the brief highlights this critical warning that leaders have been giving, that the AfCFTA could just remain a paper promise if it's not backed by, and I'm quoting here, hardened bridges and faster rail links.
But this is the answer to that. This isn't philosophical. It's a direct response to a multi-billion-dollar infrastructure gap that exists right now.
And maybe the most important part of the entire mission statement is how it plans to do it. The document is built on this explicit rejection of past global development failures.
What kind of failures are we talking about?
The common pitfalls. The mandate is to deliver trade, safety, cultural pride, but without falling into foreign debt traps, without creating socially corrosive toll injustices that lock out low-income people.
And the big one.
And yes, absolutely no maintenance failures that plague so many huge newly built projects around the world.
So the design has to be, what, self-sustaining?
Structurally, financially, and operationally self-sustaining, right from the concept stage. And that guiding principle, I think, is the true foundation of this entire brief.
Okay, so let's get into the technical side of this, because Section 1 hits with, absolute force.
It doesn't pull any punches.
It's just there in all caps. Focus today. Structure. And then this line. Structure is the law.
That's it. That one line tells the design teams everything they need to know.
It's saying that any, aesthetic novelty or architectural flair is completely secondary to pure engineering mastery.
100%. It immediately elevates the task. And it demands this total command over civil engineering fundamentals. They lay out 4 non-negotiable areas of focus.
And the first one is span logic.
Right, span logic.
It sounds a bit academic, but in this context, it feels like it's about survival, isn't it? It's about choosing the right tool for the job.
That's a great way to think about it. Are you going to use an arch, a truss, a box girder, a cable-stayed system? That choice dictates everything.
How so?
Well, if you're crossing a busy shipping lane, for instance, you need a very long span and you need high clearance. So you're probably looking at a cable-stayed bridge or maybe a major truss.
Okay.
But if you're building a repeating urban viaduct over existing city streets, something like precast box girders is going to be far more efficient and less disruptive.
And the brief demands they justify that choice.
They have to. Based on constructability, what materials are available in the local supply chain and what the long-term maintenance costs are going to be. The choice has to be structurally and, just as importantly, economically defensible for that specific place.
Which then flows directly into the second point, load paths.
This is just fundamental physics. You have to be able to sketch and fully understand how every single load of gravity from cars and people, plus lateral loads like wind or even seismic energy, how it all flows.
From the deck.
Exactly, from the deck through the piers and down into the foundations. If that load path isn't crystal clear and crucially redundant, then you've built a vulnerability right into the heart of the structure.
And for something like a heavy freight corridor, especially in a place like the Rift Valley, which we'll get to.
For sure. In a seismic zone like that, getting the load paths right is literally the difference between a bridge that operates for a century and one that suffers a catastrophic failure.
Then you have the third challenge, which is just the environment itself. Durability. Building massive infrastructure in these tropical and coastal African environments must be relentless on the materials.
It is. You've got marine air, tropical humidity, intense UV radiation. This is where a lot of standard international practices they fall short.
So what does the brief demand?
It mandates designs that explicitly handle all of it. Marine air corrosion, humidity-degrading concrete, UV exposure weakening coatings, and the cumulative fatigue from millions of heavy axle loads over decades.
They're not just looking for standard concrete then.
No, they're specifying high-performance concrete with particular admixtures and customized corrosion protection systems for every steel element.
You mentioned corrosion protection. For someone who's not an engineer, can you clarify what customized corrosion protection really means? Is it more than just a good coat of anti-rust paint?
That's a great question. It goes so far beyond paint. For a major coastal bridge, for example, you might be looking at something called a cathodic protection system.
Correct.
This is where you actually run a small, controlled electrical current through the steel itself, and that current overrides the natural electrochemical reaction that causes rust. You're basically telling the steel not to rust.
Wow.
Or you might specify these advanced multi-layer epoxy coating systems that are designed to resist salt getting in for 50, 60 years. And the connection points where steel bearings sit on concrete piers, those are corrosion hotspots. So you need highly detailed isolation barriers like special neoprene pads to keep them separate.
That level of detail is just incredible. And it leads to the fourth focus, inspection and retrofit, which I think is maybe the most interesting one.
I agree.
Because it's a policy mandate disguised as an engineering requirement. The phrase they use is no black box details.
What's fascinating here is,
Yeah.
it's this explicit rejection of design shortcuts. A black box is any part of the structure you can't see or access without, major demolition.
And this brief says that's not allowed.
Not at all. It demands that every joint, every replaceable bearing, every single structural anchor has to be inspectable. They want dedicated access gantries designed in from the start. They even want clear phasing plans for future strengthening.
Or future strengthening.
Yeah.
Maybe in 30 or 40 years when autonomous freight volumes have doubled, the design has to guarantee operability not just for the next 20 years, but for the next 100.
So every single scheme submitted has to include one of these explicit structural details and a note on the maintenance strategy. You actually have to draw the inspection path. You do. The designer has to physically locate and detail the access stairs, the maintenance laybys on the deck. They have to specify where the sensors for the structural health monitoring systems are going to be bolted. It completely shifts the conversation from how strong is it today to how maintainable is it forever.
But, historically, aren't these kinds of long-term maintenance commitments incredibly difficult for developing nations to guarantee over, say, 50 years?
Mm-hmm.
How does the brief deal with the risk that a future government might just divert the funds somewhere else?
That is the absolute critical point, and the brief tries to engineer a solution for it. The answer is in the required ESG notes, the environmental, social, and governance notes, and in the financial models they demand.
How does that work?
By linking technical choices to quantifiable metrics, like requiring a certain percentage of local steel content, which supports the local economy, or designing to reduce traffic conflict points, which is a safety governance metric, they embed the maintenance costs into the operational funding from the very beginning.
Through things like hypothecated revenue. Can you explain that?
Sure. Hypothecated revenue is just money that is legally dedicated to one specific purpose. So instead of bridge tolls going into a general government budget where they can be spent on anything, the brief often requires that that revenue is locked into an independent maintenance fund just for that bridge.
So it makes it structurally difficult for future politicians to neglect the bridge's upkeep.
Exactly. It's a structural mechanism to enforce good governance over the long term.
Okay, let's move into the actual projects, the portfolio drills. The first 5 are focused on the African heartlands, and they're all tackling these huge issues of trade, logistics, and urban mobility.
And we start with the biggest, most complex one on the entire list, Scheme 1.
This is the Lagos Lagoon AfCFTA Gateway Bridge and Transit Spine in Nigeria. It's described as a long commission-style project, a massive bridge.
And it has to be. It has to resist that highly corrosive lagoon environment while also having clearance for major shipping traffic. It's a textbook case of solving immense complexity with structural layering.
The brief specifies a dual-deck structure.
Right, and that's key. The lower deck is reserved for high-capacity, equitable transit. So you'll have bus rapid transit or BRT rail lines and the heavy freight trucks that are part of these AfCFTA logistics corridors.
And the upper deck.
The upper deck is for local car traffic and, importantly, a public promenade for pedestrians and cyclists. By separating those functions, you maximize capacity and you stop freight traffic from getting tangled up with local community movement.
The brief gets very specific on the structure here. It calls for a continuous steel or composite box girder with an orthotropic deck. That's a lot of jargon.
It is, but let's break it down. A continuous box girder is just a hollow box shape, which gives you maximum rigidity, and it's great for long spans. They say composite, which means a combination of steel and high-performance concrete. That gives you the best strength-to-weight ratio.
Okay, that makes sense.
And the orthotropic deck, that's the real high-tech part. It's a steel plate deck that's stiffened with a grid of ribs welded underneath. It's incredibly lightweight, but also incredibly strong. It's ideal for maximizing the bridge's load capacity without making the whole thing too heavy.
So it's all about long-term, heavy freight resilience.
In a very corrosive environment, yes.
And the specific detail they have to design is the pier-to-deck connection. The bearings and shear keys. Why is that one small point so critical?
Because it's where the whole thing could fail. The bearings are what allow the deck to expand and contract with the heat of the day. The shear keys are basically blocks that lock the deck to the pier so it can't slide off in an earthquake or high winds. If either of those fails, you could have a catastrophe. Detailing how you can inspect and eventually replace them is a core part of that durability mandate.
And then there's the financial model. This is where they try to combat that debt trap problem you mentioned. A PPP concession, but with capped tolls and availability payments.
This is the policy engineering in action. Capped tolls are for social equity. But the availability payments, that's the structural guarantee.
How does that work?
Instead of the private company getting paid based on how many cars use the bridge, which just incentivizes them to jack up tolls, they get paid for the bridge being available and performing to spec.
Meaning it's clean, well-maintained, safe.
Exactly. Operationally sound, 247. That financial structure forces the company to prioritize maintenance and quality, not just pure profit. It's a direct countermeasure to letting the structure decay from neglect.
And the local workforce training mandate. That's about building national capacity.
Absolutely. If you train your own local workforce in advanced steel fabrication and corrosion protection, then the nation owns the knowledge, not just the physical asset. It's sovereignty through expertise.
Okay, let's shift over to Ghana, Scheme 2. The Accra-Tama Urban Viaduct and Trade Flyover. If Lagos was about this massive water crossing, Accra's challenge is more about urban congestion, right? Choke points around the port.
Exactly. The Accra Viaduct is a pure logistics puzzle. It's about relieving the congestion around Tema Port and integrating these complex multi-node interchanges. The goal is simple. Get truck kilometers off local streets and maximize the flow of shipping containers.
The social aspect here is really interesting. The brief says the area under the viaduct has to be guaranteed as public realm.
Yes, and that's a huge deal. So often, viaducts just slice through communities and the space underneath becomes this derelict, unsafe, no man's land.
Right.
By mandating that this shaded area be formalized for community use, local markets, park and ride hubs, and guaranteed by policy, not just left to informal chance, the structure becomes a social asset, not just a barrier.
And structurally, they're pushing for precast segmental concrete box girders. Why that choice for Accra?
Speed and repeatability. Precast segments are made in a factory under controlled conditions, then they're trucked to the site and just lifted into place. It minimizes disruption in a very dense urban area.
And the critical detail is the tendon layout.
Right. The tendons are these high-strength steel cables that are threaded through the concrete segments and then pulled incredibly tight, stressing them, which is what locks the whole thing together. Detailing that layout correctly is absolutely essential for the long-term integrity of the viaduct.
Let's move on to transit, Scheme 3 in Kenya. The Nairobi BRT overpass and People's Skywalk. And this one is directly inspired by the Dakar BRT success story.
Yeah, the Dakar project, which is listed as precedent one, really proved that for transit to be reliable, you need dedicated infrastructure. You can't just paint a lane on the road and hope for the best.
So Nairobi's challenge is about creating that dedicated infrastructure in a complex, informal urban fabric.
And making it storm resilient and safe, it's about grade separation for both buses and pedestrians.
The People's Skywalk seems to be the main focus for that social integration piece. How detailed does the brief get?
It gets very detailed. It has to be a covered structure to protect people from the sun and rain. It has to integrate microstalls for vendors. And it must have universal access, elevators and stairs connecting to the existing Matatu hubs.
And it requires community co-design.
Which is critical. That ensures the structure actually meets the local economic needs instead of just imposing some sterile top-down solution. The key metric here isn't vehicle speed, it's PPHPD people per hour per direction. It's a measure of equitable throughput.
Structurally, they're looking at precast girders again, but with a focus on the expansion joints.
Right, because in a city that has big temperature swings and some seismic risk, that expansion joint is the pivot point. It has to let the structure move without breaking, but it also has to carry heavy loads and stay watertight. A leaky joint leads to concrete spalling and corrosion. It's a small detail that can cause massive long-term damage if you get it wrong.
Okay, let's jump back to Senegal, to Scheme 5, the Dakar BRT connector viaduct and Atlantic threshold. This is about extending that successful BRT line to the coast.
And the challenge here is balancing efficiency with environmental sensitivity. They need flood-resilient access, but the structure has to be visually slender to preserve those Atlantic views and the sea breeze.
The ESG integration is very specific here.
It is. The contract requirements have to explicitly include things like mangrove enhancement or building soft edge protections near the bridge footings.
So the civil engineering contract becomes part of a broader environmental strategy.
Exactly. The bridge construction has to give back to the ecosystem. Structurally, they're asking for a slender design, which means they'll have to be really meticulous with detailing the drainage to handle all the salt spray and prevent corrosion.
We're shifting focus a bit now into schemes that are really about culture, about geological risk, and ultimately about expressing national identity.
And we start with Scheme 4 in Côte d'Ivoire, the Abidjan Lagoon Cultural Bridge. This one is a direct response to a lesson learned from a previous project.
Right, the Henri Conan Bédier Bridge. The brief calls it a mixed anchor precedent. It did ease congestion, but the toll-only, car-centric design kind of limited access for most people.
So Scheme 4 is designed to structurally reverse that policy. It mandates a multimodal crossing that puts transit, pedestrians, and cultural spaces first, and private cars second.
And it has to include a shaded cultural plaza mid-span.
A plaza, yes, and dedicated fishing access platforms. It's about recognizing and integrating the traditional uses of the lagoon. The structure has to facilitate local life, not just speed traffic past it.
The real policy weapon here, though, seems to be the financial structure. Capped public tolls, but transit users cross for free.
That is a powerful structural declaration of what the nation values. It says that equitable access and mobility for working people is the priority. And even the revenue from the car tolls has to be hypothecated.
There's that word again. So it goes into a dedicated independent maintenance fund.
Right, with public reporting of all inspections. The financial model itself is designed to prevent the toll-based injustice of its predecessor.
Okay, now for a totally different kind of challenge. Geology. Scheme 6. The Ethiopia Rift Edge Viaduct and Market Access Bridge. This is about spanning the Great Rift Valley Escarpment.
This is an extremely high-stakes engineering project. You're dealing with incredibly steep topography, massive seismic risk, and the need to carry heavy agricultural trade loads.
Connecting highland farmers to markets and rail stations.
It's a critical economic link, but structurally the complexity is just immense.
The detail about integrating market stalls at the abutments is interesting. It's acknowledging the informal commerce that happens at these kinds of transport nodes.
It is. The infrastructure has to serve the existing economy. But the real challenge is underground. The brief calls for a continuous viaduct, but the absolutely critical detail is the pure foundation design.
Because of the geology of the Rift Valley.
You're dealing with fractured rock, geological faults, steep, unstable slopes. The designers have to detail the rock anchors, the micropiles, the drainage systems needed to guarantee slope stability. A failure here isn't a crack in the pavement. It's a catastrophic landslide that takes the whole bridge and a chunk of the mountain with it.
Moving south now, the Scheme 7 in South Africa, the Durban Freight Flyover and People's Deck. This is about separating that heavy port traffic from local neighborhoods.
Right. Durban's port generates a huge volume of truck traffic, which historically has fragmented and polluted the communities around it. So the structural challenge is twofold. First, physically lift the heavy freight up and away, and second, create a new, elevated public space on top of that choke point.
They've specified steel-tied arch or through girder spans, which are good for long spans. But with that constant heavy port traffic, what's the biggest structural risks they have to design for?
Fatigue. Metal fatigue. It's the structural degradation that happens from constant, repeated stress cycles. Imagine thousands of heavy trucks driving over the same weld every single day for 20 years.
It weakens the steel over time.
Exactly. So the brief requires meticulous anti-fatigue detailing. They have to specify the weld categories, design inspection hatches, and integrate a high-frequency structural health monitoring system with sensors. If they get the anti-fatigue detailing wrong, the maintenance costs will be absolutely crippling in a decade or two.
And the policy for the land underneath is also key. Formalized market leases.
It's another way to prevent displacement and create stability. By formalizing the leases, the structure guarantees economic opportunity for the communities living in its shadow.
Let's turn to the Diaspora projects now, starting in the U.S. with Scheme 8, the Atlanta KING-KAMBUF Diaspora Freeway Cap and Cultural Bridge. This feels like a structural act of, well, historical justice.
It's an incredibly powerful statement. The goal is to build a structural lid over an urban interstate, specifically in an African-American community that was historically divided by that freeway's construction.
So the structure is literally reversing urban damage caused by past infrastructure decisions.
Often racially motivated decisions, yes.
But wait, supporting parks, cultural facilities, even mid-rise buildings on a cap over an active interstate. It sounds structurally, I don't know, insane. What kind of complexity does that involve?
It is extremely complex. First, the load management is a nightmare. The foundations for the cap have to navigate around the existing freeway, so you need custom footings that don't disrupt the traffic below. Second, the cap structure itself has to handle these massive dead loads, soil, buildings, people, without deflecting.
And the critical detail they need to design.
The deck waterproofing. It's not glamorous, but it's everything. Any failure, any leak, and you get water intrusion, corrosion of the steel girders, and just a massive, unstoppable maintenance problem. They have to detail these robust membrane layers and drainage systems to guarantee it stays absolutely dry underneath.
And the implementation strategy is to link it with U.S. federal grants like reconnecting communities.
Which is smart. You use local grant money to build the physical cap, and then the long-term KMBO cultural leasehold guarantees the programming and mission on top of it.
Okay, across the Atlantic to Brazil. Scheme 9, the Salvador Bahia Diaspora Coastal Causeway and Ritual Bridge. This one explicitly blends civil engineering with spiritual practice.
It's remarkable. The project links Afro-Brazilian and Candomblé-Yoruba ritual sites with everyday transport. So the structure has to be physically resilient to the aggressive Atlantic coast, but also culturally sensitive. It has to integrate ritual procession routes and a mid-span ritual plaza.
The governance challenge there seems unprecedented, integrating a ritual calendar into the operations of a major piece of civil infrastructure.
It requires a new kind of management. It might mean certain lanes are closed for processions on specific days, which has to be built into the operational policy from the start. Structurally, the low-profile concrete viaduct seems straightforward, but the critical challenge is the pier detail in the tidal zone.
What are the big threats in that tidal zone?
Three main things: scour, corrosion, and wave loading. Scour is when the tidal currents erode the soil away from the base of the pier, which can completely undermine the foundation. Corrosion from the salt spray is just relentless, and then you have the force of the waves themselves hitting the pier.
So how do they design for that?
The pier has to be detailed with very high-density concrete with extra thick cover over the reinforcing steel, maybe even sacrificial concrete layers that are designed to wear away over decades, protecting the core structure. The structure has to physically embody resilience against the sea to keep those cultural pathways open.
And that brings us to the final project, Scheme 10. The prototype KMEO City-State Sovereign Arrival Bridge. This is the flagship, the icon.
This is the physical assertion of KMS nationhood. Its design has to be emblematic. It has to use proportional logic and stylized pylons to express a national identity. It's a bridge that carries security, ceremony, and connectivity all at once.
Then what specific spaces have to be integrated into this one structure?
3 critical layers. First, a secure, integrated immigration and security deck. That's the hard border control. Second, a dedicated ceremonial lane for state visits and official movements. And third, a pedestrian balcony with a mandated picture-perfect view toward the capital core. The bridge itself dictates the ritual of arrival.
Structurally, they're demanding a hybrid arch and cable-stayed solution. That's maximum visual drama, but also maximum complexity.
It is. It's chosen for the long span and the visual impact. The real complexity is in the junctions, where all the forces meet. The designer has to detail the exact load paths for the pylon arch junction and the deck anchorage node. These are the structural hotspots, and they require incredible precision, all while making sure the components can actually be built using African supply chains to maintain that sovereign procurement.
And it's all managed by a sovereign KING-KAMBUF infrastructure corporation using lifecycle cost scoring.
And that scoring method is vital. It means the winner isn't the cheapest bid up front. It's the design that guarantees the best long-term performance and the lowest maintenance cost over a 100-year lifespan. It ties the bridge's structural integrity directly to the nation's long-term financial health.
Okay, here's where it gets really interesting, I think. Because the brief doesn't just look forward. It forces the designers to learn from real-world successes and failure.
That's right. This whole visionary engineering approach is grounded in some very harsh global realities. The brief anchors its philosophy around three core precedents.
Let's start with the success story, the Dakar BRT in Senegal.
The Dakar BRT proved that real infrastructure is basically institutional reform made physical. The success wasn't just about having new buses, it was the dedicated structures, the flyovers, bridges, that made the system reliable and fast by insulating it from the city's traffic chaos. The lesson for all the KING-KAMBUF schemes is that reliability requires hardened, grade-separated structures, not just painted lines on a road.
Then we have the more nuanced lesson, the Henri Conan-Bédier Bridge in Abidjan, the big stanker.
This one serves as a caution against, let's call it, structural vanity. The bridge worked, it eased congestion, but its high-toll, car-centric model reinforced socioeconomic divisions. It priced out the majority of the population.
And that's what directly led to the mandate for the new Abidjan Bridge, Scheme 4, that transit users must cross for free.
Exactly. It's a direct lesson. Sovereignty can't be achieved if your grand structures only serve the elite.
And finally, the stark reality check, the AfCFTA infrastructure gap, the caution anchor.
This is the big financial and governance warning. The continent has an infrastructure shortfall of over $100 billion a year, and that's coupled with major governance and project execution problems. The lesson here is paramount. Your beautiful structural design is completely meaningless if it's not embedded in a financial and governance model that can guarantee it gets built and then maintained without falling into debt traps or being derailed by political instability.
You know, when you look at the implementation plans, the PPPs, co-delivery with climate funds, Port Authority collaborations, isn't that complexity itself a massive risk?
It is a huge risk, but the brief forces the designers to manage that complexity through the clarity of their structural design. For example, by specifying precast construction, they can package contracts in a way that uses and grows local contracting capacity. That satisfies a social mandate, which in turn helps attract specific development bank funding that's tied to local job creation. The structural choice becomes a negotiation tool.
The brief then boils all this down into two powerful guiding directives. The first one is very technical. Designing inspection routes at concept stage prevents hidden failures later.
It's a structural accountability mandate, pure and simple. If you design that Durban flyover without clear access to inspect the welds for fatigue, you are guaranteeing failure and massive costs down the line. It forces the designer to think about the entire life cycle, not just the ribbon-cutting ceremony.
And the second, more philosophical lesson. Untold transit decks carry more sovereignty than gold-plated car lanes.
And that connects the physical steel and concrete right back to the core ethos of KING-KAMBUF. It's defining true sovereignty as being rooted in the equitable movement of people and the acceleration of trade, not in the comfort of private car owners. The very shape of the bridge's deck becomes a political declaration.
And the final instruction to track all those performance targets, travel time saved, road deaths reduced, CO avoided, it makes the entire process quantifiable.
It's about building mastery through ruthless quantification. The engineers can't just propose a vision, they have to propose a solution that delivers measurable, positive returns to society and the economy. It ensures accountability from top to bottom.
So as we wrap up this deep dive, you really get a sense of the incredible intensity of the workflow this brief demands. Two 90-minute design blocks to produce these portfolio-ready boards.
Yeah, that workflow is designed to accelerate expertise. It forces integration. In that first block, you have to define your performance targets. How high is the bridge deck above the 100-year floodline? What is the design life for the corrosion protection system? And you have to annotate the KING-KAMBUF identity elements. It pushes designers past just browsing concepts and into rigorous system definition.
And the second block is where the technical rigor comes in. You have to produce the plans, the sections, and that one key structural detail, whether it's the seismic joint for Nairobi or the tidal pier for Salvador Bahia.
And you have to put the inspection notes right there on the drawing. The drawings themselves become these composite policy documents. They have to quantify the ESG overlays, the equity metrics, the safety metrics. A structural drawing here isn't just about tons of steel, it's about national impact.
So what does this all mean then? It seems to mean that this vision of nation building requires, well, it's not just architectural flair. It's rigorous structural engineering, married to an unwavering commitment to equitable finance and cultural expression.
If we connect this to the bigger picture, yes. We're seeing infrastructure being used as the definitive tool of national self-determination. The whole process is designed to create systems that are independent, durable, and that prioritize the long-term well-being of the people and their economy over any short-term political gains.
And the closing directive from King-KAMBUF, it just perfectly encapsulates this entire ethos.
It's an incredibly powerful statement. It demands the structures don't just function, but that they proclaim the nation's independence. It says, bridges are not decorations, they are weapons of sovereignty. We do not copy imperial spans. We design KAMBUF gateways that carry our people, protect our coastlines, accelerate our trade, and announce our presence on every shoreline and skyline they touch.
And the final commands are just these pure focused actions. Trace the load path, lock the detail, claim the corridor, build the span, own the crossing, expand the nation.
It's an uncompromising call for total mastery, structural, logistical, and strategic.
The brief really presents this compelling choice, between the massive scale of the Lagos Lagoon Gateway and the ultimate icon of the Sovereign Arrival Bridge. We've talked about how a free transit deck is a policy weapon, or how a ritual plaza is a cultural weapon. But let's bring it back to that structural guarantee. Given the command that the bridge's success, its true sovereignty, depends on its longevity and its financial independence, which specific, often unseen architectural detail do you think is the true weapon that guarantees that future? Is it the detailing of the reinforcement in the rift edge viaduct's pile caps, designed to stop a geological failure? Is it the rigorous anti-fatigue detailing on the Durban flyover steel welds? Or is it that multi-layer waterproofing system on the Atlanta freeway cap that prevents internal corrosion?
That's the ultimate question.
Because the sovereignty isn't really in the height of the pylon, is it? It's in the detail that survives 100 years of climate change and heavy use without creating crippling maintenance costs.
That hidden detail, whether it's the cathodic protection system or the perfectly sealed expansion joint, that is the ultimate defense of the nation's financial and physical independence. It is the structural integrity of the unseen element that guarantees the visibility and the meaning of the symbolic gateway that stands above it.
Thank you for joining us on this really deep exploration of the KAMBUF Nation Building Design Command Brief.
It was my pleasure.